Good. Now let's look at area of the plane shapes. Area. Now, when you talk of area is a space available. It's a flat surface available, occupied by a substance, right? So where you sit now is an area. The desk, the table you are using is an area. It's a surface, right? So it's a two-dimensional surface covered by a substance. You understand? So if you want to calculate the area of a space, available space, whether in a room or in a compound or in a field or whatever, all you have to do is that calculate equal squares, measure equal squares on the surface in question. So in your book, you can measure equal squares, and in your book, you can measure with centimeters, right? That's to show so centimeters. So in a large space, you can measure with meters. You can measure in kilometers. In a vast land, in a community or town, you use kilometers to do so. So kilometer by kilometer. So 1 kilometer length and the breadth 1 kilometer. Cut equal or such. Count it. That's the answer. So as you see in the table above. So forgive me, not drawn to scale. So take it like they are squares. So that is the surface. So let's say assume that this is a plain sheet, right? A metallic sheet or paper, a piece of paper, and I want to calculate the area involved. So we cut equal squares on the surface, and after counting, we had 18. So there are 18 squares. So the answer is 18 squares in centimeters, because we use centimeters to do the calculation. So the unit of measurement that you use is what you use to apply. If you use kilometers, say kilometer or square kilometer. So 18 square centimeter, 18 square kilometer, 18 square meter, 18 square millimeter. So the measurement you use to cut the one by one is what you use. Good. So this is a demonstration. But if you have a vast land, a large space to calculate the area, inconvenience will not allow you to do so. Looking at buildings around water bodies, gutters, roads, and other structures, it will not allow you to do so, permit you to do so. So what do? When you measure the length of the space available and that of the breadth and you multiply them, it gives you the same answer. So when you measure the length, it is 6 centimeters. We measure the breadth, it is 3 centimeters. When you multiply 6, 3 is what? 18. So you get the same answer. So the answer is 18 square centimeter. That is what you write. 18 square centimeter. Simple. So the shortcut, the general formula. So I come again. For perimeter, I said the general formula is just multiplying all the areas involved, right? Just multiply all the length, the total distance around the space. Good. This one, the general formula is length and breadth. Take it. General formula for finding area of any space available, no matter the shape, whether rectangular or that. So we are going to look at it, how it happens. But the condition that we have to look at is that when the breadth is not perpendicular, you create the perpendicular height. The breadth can be called height, right? It should be vertical. So make sure it is vertical. So if you see any shape which has a slanted breadth, we ignore that one and use the perpendicular breadth, which we can call height. Thank you. Take note of that. These are the conditions we are going to obey. If the lengths are not equal, then add them and divide by 2. We expect the length to be equal, just like, so rectangle is the basis for our demonstration. It's supposed to be something like this. So you know that this is equal to that, and this is also equal to that. So if it happens that this one is not equal to this one, it's not fair to pick the shorter one. It's also not fair to pick the longer one. So what do? Put the two together and take the average, which is over 2. So assuming that this is 2 and this is 5, you can't take 2, you can't take 5 as length. You are not being fair. You won't get accuracy. So we say 2 plus 5. You take half of it, you divide by 2. Either you say divided by 2 or you say take half of it. It's the same. So this is what we are going to do. So take note of that as well. Then the next one is that if there's no length or breadth, use the diagonals at their length and breadth. Because if you have a kite, you look at it, there's a kite here. Use the diagonals. And the moment you use the diagonals, it looks like half of a rectangle. You look at the demonstration. So use the diagonals as length and breadth. Because the diagonals are two. One for length, one for breadth. That's it. Then you introduce half. So anytime you use the diagonals, introduce half because it will look like a rectangle. We see how they work in the shapes above the below. Then finally, last but not least, the shape, if the shape appears like half of a rectangle, then take half of it, just like I just mentioned. So let's start with square. Square. It remains length and breadth. I've told you already. The general formula is length and breadth. It won't change. Why the changes? Instead of length and breadth, we wrote length times length. Because in mathematics, equal sides are labeled with the same variable. So it remains length and breadth though, but because they are equal, we say length times length. You don't want to change the variables because they are equal. But it remains the principle of the length multiplied by the breadth. Good. Take note of that. Parallelogram. Parallelogram. Just like you said. You see that the lengths are equal, they are the same distance. So we can choose one, which is the length. But the breadth is slanted. And we don't want slanted breadth. We want perpendicular breadth. So we create the perpendicular breadth, which we call height, and use it. So it must be perpendicular. That's all. Make sure it's perpendicular. If it's not perpendicular, create one. So length times what? Height becomes our answer. So the answer remains. And this one, it doesn't change the shape. It makes it still intact. Then the next one is rectangle. Rectangle, we have talked about length and breadth, or you can call it length and height. There's nothing wrong with that. Good. Circle. Circle. Let me use circle as the last one. Okay, circle, we have already talked about perimeter. Do you remember? Let me do it. We have talked about perimeter. And where we saw that with circle, you cut the pies, these pies, and rearrange them. Do you remember in the previous video? So it looks like this. You arrange the pie like this. The second one, you turn it upside down, arrange. The next one, good. So you just rearrange the pie. So when we rearrange, we notice that this is R. This is also what? R. But take note, this R is coming in because of the remainder we have done. If not, here, look at this side. You see, it's the circular portion which we arrange to get these two sides, to get the two lengths. Do you get it? Good. When we finish, so what does it mean? The formula says that circumference. Why did we say circumference? Circumference equals what? Pi d or 2 pi r. I think that's what we said in circumference. So if circumference is 2 pi r, it means that means circumference alone. So when we ignore this side, ignore this one as not part of the game, it means here alone is pi r. Here alone is also pi r. Do you agree to that? Do you agree? Because it is the radius that came out to form this side, the two sides. So we can ignore them. So if you want the circumference alone, it means if we share it, because it is twice of pi, twice of r. So this one here, making 2. Then one here, making 2. So twice of r. So this one is ignored. If this one is ignored, right, then we get circumference equals this plus that, which is true because it is the circumference we cut that form these two parts. But finally, though we are saying if these two sides are ignored, but we cannot ignore them, they remain that it is the radius that form this part. Therefore, using the background or the general formula of area of any plane shape is called length and breadth. This becomes our length. So This is our length. So the formula is our length, which is pi r now, times our breadth, which is r. So finally, the formula for finding area of a circle is pi r. R times r will give you r squared. I hope you get that principle. It's so simple. So simple. So here alone is half of the circumference. This is also half of the circumference because the circumference together is what gave us the two length. This one didn't come. The arrow here, the two sides didn't come from the circumference. They came from the radius. So if you want to know the component that belongs to the circumference alone, it is the two length. Yes, because that's what we have here, the two lengths. So this one pi r, this is what pi r. Agreed. But at the end of the day, because we are calculating area or perimeter, we cannot ignore this. So therefore, here must be known. So r. So length times r. Length times breadth, which is pi r times r, give you pi r squared. All right. I hope that is very clear over here. All right.